Fabini's theorem promises us that these two iterated integrals equal each other, no matter which order we go in, and they both equal the original double integral. But as it turns out, in some instances, one of the orders may be easier to evaluate than the other. So let's take a look here. Integrate the double integral of x e to the xy dA, where r is the square. X and y both run from 0 to 1. So if we try, let's do our first attempt here. Let's suppose that we want to integrate with respect to x first. So y runs from 0 to 1, then x runs from 0 to 1 of x e to the xy dx dy. So we are going to evaluate this one first. So how do we do something like this? Y, we're going to think of y as a constant. So this is x times e to a constant times x. If we think back to calculus 2, I think that suggests a integration by parts. So what we're going to do, let's try this. U is equal to x. So du is equal to dx. dv is equal to e to the xy dx, and v is equal to 1 over y e to the xy. That's all of the things that we have here for integration by parts. So the integral from y is 0 to 1 of, let's see here, so we're going to have u times v, x times 1 over y e to the xy. Plug in x runs from 0 to 1, minus the integral of u of v du. So v is going to be 1 over y e to the xy. Don't know if you can hear that. I'm in the middle of a thunderstorm right now. How about that? 1 over y e to the xy dx here. And integrate. So this is still our inside integral. Okay, y runs from 0 to 1. We plug in x is 0 and x is 1 into here. X is 1 would give us 1 over y e to the 1 times y. Plugging in x is equal to 0 would give us 0 over y times e to the who cares. It would be 0 here. And then this one, integrating e to the xy. So here y we're thinking of as a constant. And so antiderivative of 1 over y e to the xy will be 1 over y squared e to the xy. Plug in x is running from 0 to 1. 1 over y e to the y minus 0. Plug in x is 0 and 1. Plugging x equal to 1 gives us 1 over y squared e to the y. Plugging x equal to 0 gives us plus 1 over y squared here, dy. And once again, this is going to be a big mess. We need more integration by parts. This is getting really messy really quickly to try to do find antiderivative like 1 over y e to the y, 1 over y squared e to the y. Let's just cut our losses and try something else. So let's do the same problem here. But now instead of integrating with respect to x first and then with respect to y, let's integrate with respect to y first. How do we do this? Well, when we're integrating x e to the xy with respect to y, x is a constant. X is a constant, and in fact, we can do this very easily with, say, substitution. U is equal to x times y. Du, we're thinking of x as a constant here. Du is equal to x dy. So Here is x dy, that's du. X is equal to 0 to 1. And now we are integrating. Y runs from 0 to 1 becomes u runs from 0 to x of let's see here, this will be, let's see, we will end up with e to the xy is just going to be e to the u du. Okay, so when we integrate e to the u, we just have e to the u, plug in u runs from 0 to x dx. So this would be integrating e to the x minus e to the 0 is 1. And the antiderivative of e to the x minus 1 will be e to the x minus x. Plug in x runs from 0 to 1. And what do we have here? E to the 1 minus 1 minus 1 minus 0. That looks like e minus 2. So what's the point of this? What's the point of all of this? So you may wonder, why did I do all of this? This keeps going. Let me draw a frowny face here to say this. We don't want to do this. So just because Fubini's theorem says that these two iterated integrals are equal, you still have to think to yourself which order is harder, which order is easier to do. So integrating with respect to x first proved to be very difficult. It is possible to do it, and then we crunch it out, you will get e minus 2 as before. But integrating with respect to y first, this turns out to be a very easy to find antiderivative with respect to y, whereas the antiderivative here with respect to x was more difficult. So ask yourself, what's the moral of the story here? Ask yourself, which order do you want to integrate with respect to?